have E versus K curve. We have energy axis, and then we have a K axis. Okay, and then we have seen that at pi by a and at k equals to plus minus n pi by a. Okay, at k equals to plus n pi by a, we have a discontinuities. So if I plot this graph, okay, this is pi, this is 2 pi by a, okay, this is 3 pi by a, and this is minus pi by a, okay, minus 2 pi by a, okay, and minus 3 pi by a. And we have seen the graph, okay. To start here, I'm starting now here, okay. So we have seen this graph was like this, okay, and then it just moves like this, and then we go further. Okay, and then it goes like this and goes like this. Okay, so this is EK graph. Okay, and generally in all the books, okay, you see this kind of graph, and the representing this type of graph, okay, this type of EK curve, the presentation, this is called extended Jones scheme. Okay, so if you represent EK graph curve like this, so this is called your extended Jones scheme. Okay, so there are other ways also by which we can plot these curve. Okay, generally you find in literature. So the most preferred scheme which is generally used in research paper to show EK diagram is reduced Jones scheme. So this is your extended Jones scheme. Okay, now what is reduced Jones scheme? Okay, so if I plot this same graph, reduced Jones scheme means I have to plot the graph only in first billion zone. Okay, these are your bands. Okay, this is the first band. Okay, this is the second band. So if all these bands, if I draw, okay, in a reduced scale, okay, or on first billion zone, that is called your reduced zone scheme. Okay, for example, if I plot this graph like this, okay, I will some bigger scale. The same graph, if I plot on a bigger scale, okay, only restricted to pi by a and minus pi by a. Okay, and if I plot this one, okay, because your band diagrams have a translation symmetry. Okay, your band diagrams have a translation symmetry by g equals to 2 pi by a, where g is a reciprocal lattice. So I can draw all these graphs. So suppose let me draw the first graph. Okay, this is my first EK curve, first band. This is my first band. Okay, not this one. This is like a square, EX square parabola. Okay, so this is my first band corresponding to EK diagram. Now, if I want to draw this one inside this reduced zone scheme, what I need to do, I need to simply translate this graph by 2 pi by a. Okay, so if I translate this by 2 pi by a, so first it will come here and then it will come here, this graph. Similarly, if I translate this curve also, it will come first here, that will come here. So if I plot this curve, okay, if I translate, okay, this curve will go like this. This is corresponding to your second band. Okay, similarly, now if I take this one, okay, and translate this, okay, so it will come here, okay, 4 pi by. So 1 2 3, and then it will come your here, sorry, now if you translate by, so it will come here, here. So this become like this, 2 pi by. Okay. So this become your like this,
Sir,
and this curve will come 1, okay, and 2. Am I drawing right or wrong? Okay, I have. बोलिए.
sir, how it is possible to translate? Means they are the graphs, na, in that region only possible. So how we can.
I'm showing you 1 minute. Okay, why it is possible? Okay, let me check the graph first. Okay, so this will be my. Uh, okay, so this will be now. If I translate this one, 2, it will come here. Okay, 1, 2, 3. Okay, if you do 2, also if you do 3, 1, 2, 1, 2. This okay. So this is my graph. Okay, let me check again. So this is my third band. Okay, so this is called your reduced zone scheme. Okay, this is your called reduced zone scheme. Okay, now why I'm drawing like this? Okay, why my band structure has a translation symmetry? Okay, so this is the your extended zone scheme, this is a reduced zone scheme. There is a one more scheme which is not much famous or not often used. Okay, so this is the scheme which you see in a research paper. Your bands are, your EK diagram is drawn this way. Okay, you see the bands. Okay, now there is a one more scheme that is called your periodic zone scheme. So similarly, if I take this curve, okay, and okay, and I draw your E, okay, like this. So now what I can do, I can just because this is the first billion zone, okay, now whatever the shape you have in first billion zone, you can just repeat that for other zones also. So this is a graph. Now I can repeat this curve again. Okay, so this will go like this will go like this. Okay, this will go like this will go like this. Okay, similarly this happens for your all the bands, all the bands. So this is the first band. Similarly I can repeat your this second band again and again. Okay, so that is called your periodic zone scheme. Okay, so now why we are able to draw this one? Okay, because so if I draw this one, okay, this graph and again repeat this one, so this will come like this. Okay, this will come like this will come like this. So all bands I can repeat in my zones, minus 2 pi by and plus 2 by, and this is called your periodic zone scheme. Now you can see I already discussed several times that only we need EK diagram, okay, in first billion zone. So whatever happened in first billion zone, okay, other we don't require other zones. That is only repeated of those the characteristics of EK diagram is only repeated in other zones. Like we have seen when lattice vibration, we are discussing this lattice vibration. That time I also show you that omega versus frequency graph, K over graph. That time I also told you that only we are limiting our K value from minus pi by 2 plus pi by a. Okay, because that curve was periodic with K. So when there is a periodicity with K, okay, that graph is always repeating again and again. Okay, so no need to take all the K values. Only we have restricted our values from minus pi by 2 plus pi by. Similarly here, if you want to see these characteristics of this EK diagram, okay, we don't need this K values. Okay, whatever happens in pi by a, that is just mere repetition of those things. That's why, okay, this is all repetition what we are doing, so all the repetitions. Okay, that's why we prefer this your reduced unit scheme, where we plot all your EK diagram in a first billion zone. Okay, I hope it is clear to you.
Sir,
This is
sir.
so this is just a representation of EK diagram. Okay, so let me check whether I didn't mistake. Okay, it is correct. Okay, so now only what you can do, this curve, okay, these curve, these just curve, just you can repeat. So when you can repeat, you can get this periodic zone scheme. Okay, and this is the very rarely used. So we are interested only this one and this one, and most of the research paper you will see band will be drawn like this. Okay, like we are when we are drawing these branches, acoustic branches and optical branches. Okay, that were also we were drawing on only in first billion John, isn't it? Remember you that one, omega case.
Yes, sir.
Okay, so similarly here all the bands. Okay, all the bands only we draw in this is this reduced zone scheme. Okay, so so now yesterday we were discussing this effective mass, and we have shown that your m effective is nothing h cut square d2e upon dk square. Okay, so this was the formula or expression for effective mass, but in general your effective mass, okay, is a tensor quantity. Okay, so it varies, okay, in different directions. So in general, if I want to calculate my effective mass, the formula is mxx, okay, mxy. Okay, I need to calculate all the components, f xz, myx, myy, and myz, and then mzx, mzy, and then mzz. Okay, where your mij is equals to h cut square, okay, d2e upon dki, okay, dkz. So अगर mx calculate करना है, so you simply need to calculate d2e by dkx square. Okay, so this is your general formula for effective mass. Now let us discuss more about this effective
Please
mass.
decide.
Yes. Can I erase this one?
So please wait.
Okay.
सर या दो वेरिएबल के रिस्पेक्ट में डिफरेंशिएशन इसलिए लिया है क्योंकि आई और जे कंपोनेंट है ऐसा कुछ है क्या?
हाँ, MIG कंपोनेंट ना, एक्सेस चाहिए तो आपको यहाँ पर KX करना पड़ेगा, XY तो आपको KX KY करना पड़ेगा. Okay. Now if you want to calculate effective mass on a point, okay, this is in directions. Okay, now suppose you want to calculate this your effective mass on a point, then you need to calculate all the components and you need to take average out. Okay.
Sir,
Huh.
in the last two components, stars will be not there.
Star is there. Star is
There,
there.
na?
Star is there. Okay, it's just a pen of slip of pen. Okay. So now let me discuss. Okay, my effective mass more. Okay, so if I plot the graph, okay, because effective mass depends on second differential of k. Okay, so this is my E. Okay, and I know this is my E varies. Okay, like here close to the band, okay, it is almost constant, that slopes become parallel to this one. Okay, now suppose if I want to calculate the velocity Vg, okay, so Vg is nothing d omega by dk. Okay, and you know omega is equals to E upon h cut. Okay, so if I want to calculate Vg, that is nothing, that is equal to 1 upon h dk by dk. Okay, so now I have been given this relation, E versus K relation. Okay, so if I want to calculate that my group velocity inside this velocity of electron in this zone. Okay, so what I need to do, I need to just differentiate this curve. Okay, so if I differentiate this curve, these are the points of inflection. Okay, where this graph is becoming, here you have x square and then it is changing direction. So these are the points of inflection. Okay, now if I want to plot Vg, okay, the group velocity Vg, okay, so I need to differentiate this equation. Okay, so this is x square. So if I differentiate x square, this is the e square na, h this is k x na, this is k square. My energy is what? Proportional to k square. Now if we differentiate this one, this become k. So if I want to plot a velocity, this graph will go like this, straight line, because it's a constant slope. Here also it will go constant slope. Okay, and then it will decrease, and when slope becomes 0, it become 0. Okay, so this will be my like a sine curve. Here I want, this is k is negative, so this will go straight, and then it will go like this. Okay, so this is like a your sine wave. Exactly, it is sine wave, but here I'm showing that this is a proportional to x square. Generally it is not proportional to x square. Okay, so you always get like a sine type of curve. Okay, we'll see when we'll tight band approximation, then we'll get the exact relation with tight band approximation, and then we can show that this curve is sine curve. Okay, so this is my velocity. Okay, now if I want to calculate my this second differential d2e by dk square on this curve. Okay, so how can I plot? Anyone? Let me rub this one now. So this you can plot. Okay, so I don't have space, so I am drawing one more curve here. Okay, so this is my, this is over. Okay, now I want to plot d2e upon dk square. Okay, so you see, now again I will differentiate this. So now this is proportional to k. If I differentiate, this become constant. This become constant. Okay, in this region, and then what will happen after that? After that is decreasing, it's going down. So your second differential also will decrease. Okay, it will decrease. So here it is constant, and it will decrease. Okay, and it will touch somewhere 0 axis. So it will go like this. Okay, is it visible? So let me draw. This is थोड़ा ऊपर draw करने दो, तुमको दिखेगा नहीं ऐसे तो. So I have this curve. Okay, now I am drawing what? I am drawing second d2e, okay, upon dk square. Okay, so what happened? This curve initially is constant. Okay, and then it goes to 0 at inflection points. Okay, so this is the d2e upon dk square. Now I need to plot my m star. Okay, effective mass. So effective mass is nothing, m star is your h cut square d2e upon dk square. So if I want to plot this one, so you can see here it is constant, so this quantity will also become constant. Okay, so my effective mass will be also constant. Okay, so my effective mass will be almost constant when this is constant. Then what will happen? It will start decreasing. So when it start decreasing, this differential second derivative, so this decreasing, that means my m should increase, so my mass will increase. Okay, and when this becomes 0, so my mass will become infinite. Okay, that means there will be discontinuity. So my effective mass will change in this way. So this is my m star. Okay. Now after that, what happens? It goes in negative and start increasing in negative direction. So now what will happen? There will be discontinuity. Okay. There will be discontinuity. Okay. Suppose this is my zero axis. So when it's go negative, my mass will also go negative. Okay. Here, because it is a infinite here. Okay. It will start again. Now it is increasing in negative direction. So my mass will decrease and it will go like this. So this is my m star curve between pi by a to minus pi by a. Okay. I hope you understood what I'm trying to say. Okay. I have a EK diagram. Okay. And qualitatively I have drawn velocity graph, second differential graph. Okay. And from I have drawn here m star graph. Now here it's showing that your effective mass is negative. So what does mean effective mass का negative होने का मतलब क्या है? Okay. So
Sir,
हाँ
please explain the negative part.
I'm explaining ना. Okay. So now it is increasing what in negative direction ना?
Yes.
It is decreasing. Now it is increasing in negative direction. So it is increasing means now your m star should decrease.
Decrease in negative.
So it is infinite here. It is infinite here. Okay, this point is inflation point. Okay, so I'm not drawing properly actually. This is my inflation points. Okay, so these are my inflation points. So now it becomes discontinued here. Okay, at inflation point. So it will start from here, this line, and it will start from here, this line. Okay, so now it is decreasing. So that means now it will increase in negative direction. So my mass is increasing from discontinuity, and this is the point of inflection. So from here it will start increasing. Okay.
Yes.
Now the concept is what here. Why my mass is negative? That is important. That's something I want to discuss. That's why I'm plotting this graph. Okay. So effective mass is negative. Effective mass is negative means what? That we are at the boundaries. Okay. So we are at the boundaries now. Effective mass means you when you apply electric field, how your mass responds. Okay, if mass is moving slowly, that means mass is heavy. If a mass is not moving very fast, that means the mass is less. Okay, so effective mass is basically what? The mass of the electron in the crystal, because crystal has a potential, so it's not your electron is not free. Now negative mass का मतलब क्या है कि when you apply some force, so instead of moving in the direction of force, sometimes what happens, your electron behave differently. Okay, at the boundaries it get reflected back. Okay, why? So because we know that the Bragg condition. Okay, Bragg condition is what? Bragg condition is your 2d sin theta equal to n lambda. So whenever your electron wavelength is equal to the wavelength of the wavelength will satisfy Bragg reflections. So what will happen at boundaries? So your electron is somewhere in this k position. So when I apply electric field, so electric field it will apply force on the electron and it will increase its momentum. So when momentum will increase, okay, momentum will increase, and it means momentum is equal to h cut k. Okay, momentum is equal to what? H cut k. So this k value will also start increase. So suppose my my electron k values are somewhere near to boundary. अब जैसे मैंने इलेक्ट्रिक फील्ड लगाया उसका k वैल्यू बढ़ जाएगा. जैसे उसका k value, that k value will increase, it will reach the boundary and it gets reflected back. That get diffraction. Okay, so because of this diffraction, what happens? You are applying force in a suppose in x direction, the electron is moving opposite to the force. That's why it behaves like a your negative particle or negative mass. Okay, and in the case of real crystal, this is very complicated. Just now I told you that when I apply force, electron moves opposite, but this is not always true. In real crystal, your electron can move in any direction. That is a complicated thing. Okay, that's why these are simplest graphs. Okay.
सर
हाँ.
एक बार ये मतलब ग्राफ से जो आपने एक्सप्लेन किया वो एक बार रिपीट करोगे, मतलब वो रिपल्शन जो बोल रहे हैं वो समझ में नहीं आया.
So when you are suppose this is your k value here. Your electron is k value is velocity, na? So your k value is near to this boundary. Okay. Now you're applying electric field. Now what electric field will do? It will apply force. If force will increase momentum, momentum will increase your K value. So suppose you are here and now you apply electric field. Now you reach, suddenly you reach your K, you reached here. And when you reached here, the Bragg condition will satisfied. 2d sin theta equal to n lambda. 2d sin theta equals to n lambda. And instead of going in the direction of force, your electron will move opposite direction. Okay, that's why it behave like a negative mass.
Means it collides, that's why it reverse.
Diffraction, not collide, exactly collision, it is a diffraction.
Okay.
Okay. So do you want me to plot this graph again, or you understood this graphs? You can find any book, you can find these plots, huh? You can plot these graphs. So this is your effective mass. Okay. Okay. Now let us do some problems. Now I have been given this E, okay, equals to h cut square, okay, K 2k minus 3 upon 2m. Okay. Now you need to find out, calculate the effective mass. Okay. Simple question है. So you want to find effective mass, you just need to differentiate twice this expression. Okay, so if I differentiate this expression, d2e upon dk square will give me what? H cut square 2m. Okay, so this is h cut square 2m. This become 2k square minus 3k. Okay, so if I differentiate this one, this will give me what? This will give me 4k minus 3, and I can write my effective mass is equal to h cut square, this value, okay, h cut square upon 2m. Okay, I need to differentiate twice.
Sir 4 आएगा सिर्फ ना?
दो बार करना है ना, अभी एक बार ही किया है.
1/4 आंसर आएगा.
So if I differentiate this one, d by dk, okay, I'll get h cut square 2m, okay, then 4k minus 3, and if I differentiate twice, okay, this will come h cut square upon 2m into 4. Okay, this means 2, okay, 2 h cut square m, okay, so this is h cut square and 2 h cut square, this become m is cancel out, so this is coming out m by 2. Okay, where m0 is what? M is a free mass of electron, so your effective mass is half of the free mass of electron. Okay, now I have some more problems. This came in GATE 2018. Okay. So they have given you EK curve. Okay. EK curve as a E naught minus half cos K. Okay, where this W and E naught are constant, where W E naught are constant. Okay, okay, so you're asking calculate the effective mass near the bottom of the band. Okay, near the bottom of the band. Okay, so near the bottom of the band means what?
K tends to
K
0.
is 0.
K tends to 0. Very good. Okay, K0, K tends to 0. So just calculate d by dk. So d by dk you minus half omega cos you do this from sin k, okay, and a by 2, so a will come. Similarly, if you difference d2e upon dk square, this will give you a upon 2, okay, this will give me cos k, okay, this will become a square. Now I need to calculate near the band edge, okay, so I need to calculate this expression, okay, near k tends to 0, so this will become a square cos k 0 1 a square by 2, okay, and the effective mass will be what, h cut square, okay, a square 2. So this should be the answer. Yes. Okay. Now let me solve one more problem. Okay. This problem came in NET JRF 2016, June 2016. Okay. So at JRF June 2016. Okay. So there they are given EK relation. Okay. A minus B cos of 2K. Okay. Where K varies from 0 to pi. Okay. So he asking the electron in which range of K the electron has hole like behavior. Okay, hole like behavior. Okay, of what range of K? Okay, of, okay, so electron is behaving like a hole. So ये पूछ रहा है K की किस वैल्यू के लिए इलेक्ट्रॉन जो है that will be behaving like a hole. Hole का मतलब क्या है? That electron should have, your hole should have a negative mass. ठीक है ना? Hole का मतलब क्या है? That electron behaving like a hole means it should have a negative mass. So which range it has a negative effective mass? Okay. So first we need to calculate effective mass dk square. Okay, so that क्या हो जाएगा? A minus B. Okay, minus B you sign. So this become 2A sin K. Okay, and again when you do it. Okay, so what will you get? Let me do it one by one. So d by dk is your B 2A sin K. Okay, and d2E upon dk square. Okay, this will be your 4BA square. You do it this one. This will be cos 2K. Okay, so my mass will be now h cut square 4BA square cos 2K. ओके, अब बताइए ये नेगेटिव मास नेगेटिव कब होगा? कॉस नेगेटिव कब होगा? क्या रखेंगे यहाँ पे नेगेटिव हो जाए? के की वैल्यू क्या रखें कि नेगेटिव हो जाए?
pi by 2.
Okay, so if I write 2k equals to pi by 2. Okay, so pi by 2 पे क्या होता है? You have this graph ना? So all STC. So here if you anything greater than pi by 2, okay, this become negative. Correct? ऐसा ही है ना?
K वैल्यू pi by 2 रखेंगे.
K की वैल्यू pi by 2 कैसे रखेंगे भैया?
cos pi ये हो जाएगा.
cos pi minus में आ जाएगा ना? cos pi minus में आ जाएगा.
cos pi चाहिए. अच्छा, चेक करेगा फिर से. ये 2k है ना यहाँ पे. if you put pi by 2 cos pi minus 1. Okay, the range should be between this one, between these things. The range should be between this thing. Okay.
K की वैल्यू पाई बाय 2 रख देंगे.
हाँ, K
K
की
K की वैल्यू पाई बाय 2 रखने से क्या होगा?
cos पाई बन जाएगा, -1 आ जाएगा.
हाँ,
minus
और तो रेंज बताओ, रेंज बताओ. इज आस्किंग रेंज. अगर मैं k इक्वल्स टू पाई बाय 4 रख दूं तो क्या आएगा? इफ आई राइट k इक्वल्स टू पाई बाय 4 क्या आएगा? If I put pi by 4 here, this become pi by 2. बताओ.
जाएगी मास.
The answer is given. Okay. The answer is given between pi by 4. Okay.
infinite हो जाएगा ना
And
sir?
k and 3 pi by 4. So cos k कब नेगेटिव होता है? pi by 2 प्लस पे नेगेटिव होता ही नहीं होता है. Any angle cos 2k. ये cos क्या होता है? 90 प्लस थीटा पे नेगेटिव होता ही नहीं होता है. मैं पूछ रहा हूँ. If I put 90 प्लस थीटा तो cos
It
थीटा
will be
नेगेटिव
negative.
Yes, sir, negative.
नेगेटिव साइन थीटा नहीं होगा क्या? Okay, so anything above 90 is negative. Okay, so that's why I'm writing this 2k is equal to pi by 2. This is limit na, it should be greater than this one. You go anything greater than this one, this become negative. So I'm putting your 2k is equal to pi by 2. Okay, so now my k will be what? Pi by 4. Okay, k will be pi by 4. 2k equals to pi by 2, so k will be my pi by 4. It should be that like this only. So this should come. This limit is given ka, angle is ka. Okay, so I'm putting k equals to pi by 2, so this k will become pi by 4. So the one range is pi by 4. Okay, now second range is 3 pi by 4. 3 pi by 4 का मतलब क्या होता है?
पाई माइनस पाई बाय 4 1.
270 degree.
Okay, so pi minus pi by 4. Okay, cos. So this cos is positive or negative?
नेगेटिव आएगा.
Negative आएगा ना? Then that's why I'm telling anything this is less, so this is the range of your k. So
सर
हाँ,
सर मुझे इस क्वेश्चन में अप्रोच समझ में नहीं आया. जैसे आपने कहा कि किस रेंज के लिए हमारा जो इलेक्ट्रॉन है वो होल की तरह बिहेव करेगा.
तो होल का मतलब क्या?
Then-
उसका किस रेंज में k की किस रेंज के लिए हमारा इफेक्टिव मास नेगेटिव आएगा? ओके, तो हमको देखना है कि अब हमारे पास ये तो पॉजिटिव है, ये तो पॉजिटिव है, कांस्टेंट है, तो किस रेंज में ये नेगेटिव हो जाएगा? कॉस के जिस रेंज में ये नेगेटिव हो जाएगा उस रेंज में आपका मास नेगेटिव हो जाएगा. व्हाट इज माय पॉइंट? So anything greater than pi by 4, pi by 2, okay, you can put any values and find out whether cos is positive or negative. Okay, slightly greater than pi by 2, you put the values. Okay, let me check the graph also if you're not understanding this way.
सही है सर. pi by 2 और 3 pi by 2 पे हमें हमेशा नेगेटिव वैल्यूज
Okay.
मिलती है.
So if I plot this way, na, angle, this is my angles, omega t. Okay, so pi by 2 पे क्या आता है? ये 0 आता है. Okay, pi by 2 आगे क्या होता है? नेगेटिव नहीं आ रहा है. cos. Any angle is greater than pi by 2. So if
Yes,
this
sir. Now
so
got from the
so
graph.
this 2k is greater than pi by 2. Okay, so you have this range. So anything greater than, then your limit is pi by 4. Same thing you do on this end range also. Clear?
Yes, sir.
Yes sir.
Okay. Okay. now एक क्वेश्चन आपको करना है. Okay, the energy versus wave vector EK relation near the bottom of a band. Okay, near the bottom of band for solid can be approximated as. So you have been given is E, okay, A K square B K 4. This is the relation is given, okay, where the lattice constant A, okay, A small a is given 2.1 angstrom, okay, and the value of A and B are, the value of A is given to 6.3 into 10 raised to power minus 19, okay, and the B value is given, okay, 3.2 into 10 raised to power minus 20 J. These values are given, okay. So you asking at the bottom of the conduction band the ratio of effective mass of the electron to the mass of free electron, okay. So you need to calculate M star versus Me, okay, at the bottom of conduction band, at the bottom of conduction band. Calculate. So first we need to calculate the effective mass, okay. So D upon dk, okay. So this will come what, 2a k, a square is there, okay. So a square k plus b4, okay, b and it'll come 4 b a4, okay. So this become 3, sorry, this k become 3. So b a4 k3, and if I differentiate further, do d2e upon dk square, this will give me what, 2a square plus 12 b a4 k square. So this is now I have to find out this expression d2e upon dk square at k tends to 0. So I'll be having only this component a square. So now if I want to calculate the effective mass, okay, so the effective mass will be h cut square, okay, upon 2a square. Now a value is given, capital A value also given, and you know the free mass of electron is 9.1 into 10 raised to power minus 31 kg, okay. Calculate this value and tell me the ratio.
So 8.61.
नहीं 8.61 नहीं है, इतना ज़्यादा कैसे आ जाएगा, चेक करो कैलकुलेशन, चेक करो एक बार. So M star, okay, this is 6.6 into 10 raised to power minus 34 kg. So it becomes 68, okay, and this 6.61 will come one more time, 6.6, okay, 6.62 or 6. Okay, whatever you want to write, okay, 6 approximately. So now this is 2. What is the value of A? A is given 6.3 to 10 raised to power minus 19, okay, and A is given 2.1. So 2.1 into 2.1 into 10 raised to power angstrom minus 20. So now you find out kitna aa raha hai. So this power is what much? 19, 20, 39, 68,
Sir, that one H value, no, sir, 6.62 point on the power of minus 30.
6.62.
Sir, H value, no, sir, that one.
हाँ हाँ हाँ.
H cut value.
Oh, you want h cut value? Yes. Okay. Okay. Correct. Okay. So the h square by 4 pi. So, h cut.
10 power minus 3.
So 4 to 10 to the power 1.05 you can do also. So 3.5. Okay. A square also you want. So better to write 1.05. Correct. So better to write 1.05. 1.05 and this is also 1.05. Correct. So now how much is coming? Ratio कितना आ रहा है? M star versus ME का ratio कितना आ रहा है? Or shall I give homework this one? Okay, so this is homework.
2.180 into 10 power minus 3 0.22180.
2 point
0.21.
18
0.2180.
10 to the power minus 1. Okay, that means coming 0.218. Okay,
Yes, sir. Yes, sir.
this is the correct answer.
सर आंसर क्या आ रहा है?
0.2 आ रहा है. 0.22 के आसपास 0.218 के आसपास आएगा आंसर. 0.218. Okay. Now I'm going to solve some problem from net. Okay, and these are three similar kind of problem, but there's a little bit change. So you will understand when this type of problems are coming, what you supposed to do. Okay, so the first of all, let me do a simple problem. Okay, so you have been given an EK curve. Okay, this is E naught minus B cos kxa, okay, plus cos kya, okay, and plus cos kza. Okay, is the EK curve is given, and these type of expression we get using when we do tight binding approximation ना, तब इस तरह के एक्सप्रेशन हमको मिलेंगे. कल हम देखेंगे when we derive the expression from time binding approximation, this will give this type of relations. Okay, so E naught minus B, so this is the relation is given. Okay, now you're asking find out the effective mass M star, okay, near bottom of the bandage, bottom of bandage. Okay, so near k tends to 0. So what will do? कैलकुलेट करो, बताओ कितना आ रहा है. ये तो ऐसे क्वेश्चन तो हमने खूब करे हैं पहले, लैटिस वाइब्रेशन में भी कर रहे हैं. When k tends to 0, then you what you write? You approximate cos k value by
1 minus kx whole square by 2.
or x is equal to 1 minus x square by 2. So ये तो सिंपल है. कितना आ रहा है?
सर इसके पहले क्या कर रहे थे वैसा किया तो मतलब cos का डिफरेंशिएशन साइन किया वैसा करके उसके बाद लिमिट सब्स्टिट्यूट किया k टेंड्स टू 0 तो आंसर सही नहीं आया.
आया था, सही आया था. तो इसमें कैसे करोगे?
तो मतलब
करो इसमें करो,
इसमें
करके देखो.
3 कंपोनेंट है ना सर, जब स्क्वायर करेंगे तो बाद में k की टर्म आ जाएगी, तो फिर
हाँ.
10 to 0 का पुट कर देना.
तो हाँ, तो वही तो डिफरेंस कैसे करोगे? या फिर आप या तो फिर कंपोनेंट फॉर्म में करो. ओके, तो इसीलिए मैं क्वेश्चन दिया, पहले तो आप सिंपल फॉर्म से करो और फिर कंपोनेंट फॉर्म में करके देखो. और कंपोनेंट फॉर्म में इसने पॉइंट पे पूछा है तो जो आ रहा है उसका एवरेज निकाल के देखो. व्हाट इज पॉइंट व्हाट आई एम सेइंग?
नो सर एक्चुअली
you calculate the components. So yeah, either you do approximation or either you get components and check it. Okay, so whether we are getting same answer or not, you get the components and take average of that 9 components. Okay, average of 9 components. So suppose your sum of components you're getting 0, and then you can take component 9s. So if you can do it, you can, if you that method you can applicable here, you can apply there. Otherwise you do it like this.
सर मतलब डिफरेंशिएशन करके वैसा नहीं आएगा आंसर मतलब cos का
आप देखो ना, आप देखो कैसा आ रहा है कि नहीं आ रहा है. अगर मैं इसको रिफ्रेश करता हूँ कंपोनेंट फॉर्म में, x k x k y k z है, हो रहा है क्या? चेक करो. m star. Okay, so mij equals to what? h cut square d2e upon dki. Okay, dkz. ट्राई करके देखो, इससे आ रहा है क्या? कंपाउंड फॉर्म में आ रहा है क्या?
आंसर क्या है? h क्रॉस स्क्वायर बाय bs स्क्वायर।
ओके, आंसर हाँ, h कट स्क्वायर bs का ऑप्शन दे रखा है क्वेश्चन 7। उसने अच्छा है क्वेश्चन 7। हाँ सही है। ओके, द आंसर इज h कट स्क्वायर bs स्क्वायर। बाकी लोग का भी आ रहा है क्या?
यस सर।
ओके,
Yes, sir.
और कंपोनेंट फॉर्म करने से कंपोनेंट के फॉर्म से आएगा क्या क्वेश्चन? आएगा क्या?
सर लंबा हो जाएगा।
नहीं, अगर लंबा भी हो जाए एक बार ट्राई करके देखो कि कंपोनेंट से निकल रहा है कि नहीं निकल रहा है। ओके, अगर निकलता है तो मुझे बताओ। होमवर्क है, अगर उस कंपोनेंट फॉर्म से निकलता है
सर आ जाएगा, 2 बार डिफरेंशिएशन करेंगे तो 2kn आ जाएगा फिर।
सर क्या आंसर आ रहा है?
ये h कट स्क्वायर b a स्क्वायर।
मेरा h स्क्वायर अपॉन 3ba स्क्वायर आ रहा है। मतलब cos का जब सब्स्टिट्यूट करते तो cos 0 का 1 हो जाता है और 1 + 1 + 1 3 हो गया।
हाँ, तो
सो
डिफरेंशिएट करो तो वो 3 तो गायब हो जाएगा ना। यू हैव e k e0 माइनस b, अब मुझे थोड़ी रटा हुआ है, माइनस k x स्क्वायर a स्क्वायर बाई 2। ओके, सो ये 1 बन करके 3 बार आ जाएगा। ठीक है,
नहीं सर, ऐसे नहीं, मैंने वो डिफरेंशिएशन लेके किया है।
and then you do it like this will come k x square k square a square by 2, ये आ जाएगा रिलेशन। now you differentiate this one 2 times, it should come like this। तुमने कैसे किया?
डिफरेंशिएशन लिया जो कि आया sin k के कंपोनेंट्स आए, उसके बाद उसका फिर से डिफरेंशिएशन लिया तो मुझे cos मिला। बाद में लास्ट में cos k टेंड्स टू 0
हाँ,
किया
तो तुम्हारे
और
पास
उसके बाद
तुम्हारे पास ये आया ना।
हाँ 3ba स्क्वायर वो आया।
हाँ, तो साइड बाकी बाकी कंपोनेंट y का कंपोनेंट भी निकालो, सारे कंपोनेंट निकालो। ओके, you calculate all the components, so you getting this one, second component also will come like that, so you what you will get, you will finally you get 9ba square। ओके, ऐसा कुछ मिलेगा तुमको या फिर कुछ मिलेगा एवरेज करने से? सो व्हेन यू डू
सर 9 नहीं मिलेगा सर, 3 टाइम्स ही मिलेगा ये।
हाँ 3 टाइम्स, सो यू गेट दिस वन ना।
लास्ट मेरा आंसर h क्रॉस स्क्वायर अपॉन 3ba स्क्वायर आ रहा है।
9 कंपोनेंट का एवरेज लेने पे
सर यहाँ नहीं
बाकी
समझ
बाकी
में
बाकी कंपोनेंट भी निकालना पड़ेंगे ना। बाकी कंपोनेंट भी निकालो और फिर उसका एवरेज निकालो। एक क्वेश्चन मैं कराता हूँ, उसमें देखो कैसा आएगा, देखो जिसमें एवरेज करना है, वरना आपका आंसर मैच नहीं करेगा। ओके, so you have the same type of relation ek। okay, now it can beta, okay, cos kxa, okay, plus cos kya plus cos kza। okay, this question is given. Now you have to find out the effective mass at the boundary of first billion zone। okay, so boundary of first billion zone, that means now you have to find out this is equal to plus minus pi by। अब ये कैसे करोगे? अब इसमें तो तुम यू कैन नॉट ओपन एक्स स्क्वायर ना। नाउ यू कैन नॉट एक्सपांड दिस k by pi, so you calculate components, so calculate all the components and take the average and tell me the value what is coming now। Question 6।
Sir, will you please tell components लेने हैं मतलब ICAD JCAP में कन्वर्ट करना है
कन्वर्ट किया आपको फॉर्मूला में लिखा ना, बोर्ड पे फॉर्मूला लिखा था आपको, जस्ट
तो
डिफरेंस।
ऐसे ही करेंगे ना सर, पहले डेल ई बाई डेल के एक्स, फिर
यस,
डेल
हाँ भाई, आपको आपको अगर एम एक्स निकालना है तो आपको ई को विद रिस्पेक्ट टू के एक्स के 2 बार डिफरेंशिएट करना है, ये सब तो जीरो हो जाएंगे। गॉट योर पॉइंट? वी वांट h का स्क्वायर, दिस विल बी h का स्क्वायर de अपॉन dkx स्क्वायर। ओके, नाउ कैलकुलेट de अपॉन dkx, कितना आएगा? बीटा कॉस का क्या आ जाएगा? साइन kx a, और ये a और आ जाएगा माइनस a बीटा। इफ यू डू नाउ d2e अपॉन dk स्क्वायर, क्या आ जाएगा? माइनस a बीटा। ओके, you have to take this always positive, okay, positive value this one, minus a beta cos kx a, okay, और a square बाहर आ जाएगा। now you want this is at pi by a, okay, so a square beta cos pi by a, so -1, okay, so what you got? pi by a -1, so you got a square beta। तो इसी तरह बाकी कंपाउंड निकालो, बाकी सारे कंपाउंड निकालो, बताओ कितना आ रहा आंसर? बीटा ए भी जाएगा ना, बीटा ए स्क्वायर, ठीक है, बीटा ए स्क्वायर आ गया। Now if you calculate myy, that will also come beta a square. Okay, if you calculate mzz, that will also come beta a square. Okay, all other components will come 0. Okay, I suppose बाकी सारे 0 आ रहे हैं ना?
यस सर।
So all components will come 0. Okay, so now you have m star. You first calculate m star. So mx is you getting this beta a square. So now if you add all the things, so you get 3 beta a square. Now components are 9. Okay, components are 9. So answer will come beta a square upon 3, and some h cut square also there. Okay, just like check. So this you got this expression, you get this one. So you got mxx, what you get? mxx you get h cut square upon beta a square. Okay, now you sum all the components, so you will get what? 3h cut square beta a square upon 9 components. So answer should come h cut square 3 beta a square if you're calculating point. Are you getting this one?
यस सर आ गया।
So are you getting my point? See, अगर calculate कर सकते हो तो calculate करो. Now suppose if you can simplify near k is equal to 0, you can simplify. Okay, then you will get whatever the value, exact value, if you in terms of k. If it's not terms k, kx, ky, and they are asking tensor, then you need to write a tensor. Okay, but they are asking value at some point, then you need to calculate the average. Okay, so now last question, can you calculate average and tell me whether both the answers are same or not? Last question, what we did, simplifying k. Now if you don't simplify, just calculate components and take average and take the values of m factor at cases to 0, and then you take what is the value, what is the answer is coming. So this will be same, na? d2 will be same there also, instead of mine.
Yes, sir.
सेम आएगा,
Same आ रहा है sir.
सेम आएगा आंसर। तो फिर आंसर में गड़बड़ क्यों है, वही तो मैं कंफर्म चेक करना चाहता हूँ। इसमें 26 में क्वेश्चन डी दे रखा है, ओके, एंड इसमें दे रखा है आपका दिस वन, बॉटम द बैंड क्वेश्चन 7। सो व्हाई देयर इज अ डिफरेंस इन आंसर? एक आंसर सही दे रखा है क्वेश्चन सेम में। ओके ओके, मैं इसको चेक करता हूँ। दिस नेट JRF क्वेश्चन नंबर 6 and 7, प्लीज you also see this. Okay, let me discuss this tomorrow because I got answer difference in answer. So वो एक क्वेश्चन में हम पॉइंट में निकाल रहे हैं तो हमारा आंसर सही बता रहा है, और उसी क्वेश्चन को हम अगर पैरेलल क्वेश्चन को अगर हम पॉइंट में निकाल रहे हैं तो हमारा आंसर चेंज आ रहा है, ऐसा क्यों? ओके, सो दैट लेट मी चेक दैट वन. ओके, सो इसका आंसर तो ये दे रखा है h कट स्क्वायर 3 बीटा a स्क्वायर. Okay. So now I'm giving you homework. Okay, you tell me same question is there. अभी पता चल जाएगा. e के a cos kx a, okay, plus beta cos ky a, okay, plus gamma cos kz. Okay, I got the answer. Okay, so now there is the difference in these two questions. Okay, okay, the question what we are doing, taking components and we are taking average. That time these asking the value at a point. Are you got my point? Okay, so you have a crystal. Okay, you have a 9 components. You have 9 components. Okay, and he's asking a value at a point. That's why I'm taking average of this all thing point. And that question, what they're asking your k value near the band edge. They're not asking any point. Okay, so that's why we are applying approximation. That is the difference between two questions. Okay, have you got my point?
Yes, sir.
So if your components is asking any point, then you need to take average. Okay, if it is the range, is near the band means what? It's a range. So then near the range they are asking. That's why we have done this one approximation. Okay. And the EK curve also, you have to remember that here they are like a free particle. Near the band edge is behave like a free particle. If you go at the boundaries, this curve changes. So here we can assume this is a free particle also. Electron is a free particle also near the band edge, because the relation is E is equal to K, E is proportional to K square. Okay. So now this is one question. Okay, so this relation is given where alpha, beta, gamma are constant dimension energy. They are asking what is the effective mass tensor. Effective mass tensor. Okay, what is effective tensor at the corner of the first billion zone? Okay, so they are asking pi by a, pi by a, pi by a. At this point, what is the tensor? They're not asking average, they're not asking value, they're asking what is the tensor. Okay, so this is your homework. Okay. Now बस खाली इसमें एक ही टॉपिक बचा हुआ है, दिस टाइट डिमांड अप्रोक्सीमेशन. उसको हम कल खत्म कर देंगे. कल हम थोड़ा लंबा क्लास ले लेंगे. ओके, और उसको खत्म कर देंगे. ओके, सो आई एम स्टॉपिंग हियर. एनी क्वेश्चन?
सर हमने जो लास्ट प्रॉब्लम किया बीटा कॉस के, उसमें से जो हमने कंपोनेंट्स निकाले, कंपोनेंट निकालने के बाद हमने एम स्टार का जो फॉर्मूला लिखा, उसमें मतलब 3 ही कंपोनेंट परसिस्ट होते हैं, जिसकी वजह से 3 बीटा स्क्वायर आ गए. तो वो मतलब 9 नीचे मतलब एवरेज भी
बाकी डायरेक्शन में 0 है ना, वही तो मैं भी प्लॉट किया. अगर आपको बाकी सारे कंपोनेंट तो 0 है ना.
हाँ, वो समझ में आया, लेकिन उसके बाद
तो ये आपकी सारी डायरेक्शंस हैं. ओके, अगर आपको एवरेज निकालना है तो सारे कंपोनेंट का एवरेज निकालना पड़ेगा ना. कंपोनेंट तो 9 है.
हाँ, सही बात है. हाँ सर, तो इस मतलब 3 नीचे आना चाहिए ना, 9 भी नीचे आना चाहिए और 3 भी नीचे आना चाहिए.
नहीं, तो उल्टा. अभी तो आपने मास का निकाला, हमने तो जब आप पूरा निकालो ना मास तो आपका ऐसे आएगा 3 एट एच कट स्क्वायर बीटा ए स्क्वायर आएगा आपका टोटल मास सबका करोगे तो सबका. ओके, एम एक्स आपका ये आएगा, एम वाई वाई आपका ये आएगा, ओके, और टोटल करेंगे तीनों का, एम जेड जेड एच कट स्क्वायर बीटा ए स्क्वायर आएगा। ये वैल्यू तो मैंने निकाला डी टू ई बाई डी के एस को निकाला था ना, हमने अभी कैलकुलेट किया था डी टू ई अपॉन डी, उसकी वैल्यू थी बीटा ए स्क्वायर। तो ये टोटल तो टोटल टोटल करके तो थ्री हो जाएगा, बाकी सारे कंपोनेंट जीरो हैं, और फिर 9 से डिवाइड कर देंगे तो ये 1 एच कट स्क्वायर 3 बीटा ए स्क्वायर आ जाएगा।
क्लियर क्लियर सर, थैंक यू।